In base 10, the number 2013 ends in the digit 3. In base 9, on the other hand, the same number is written as 2676, base 9, and ends in the digit 6. For how many positive integers b does the base b representation of 2013 end in the digit 3? So to show what's happening when we convert to base 9, this is how we do it, dividing 2013 by 9 and going as follows here. So the remainder here that we get is 6. That checks out because the last digit there is 6. The remainder that we get here when we divide 2013 by 9, this is the digit that the base 9 representation will end in. Given that information, what has to be true for the base b representation of 2013 ending in the digit 3 is that when this is the case, the number is going to divide 2010 because they're 2013 minus 2010 is 3. There would be a remainder of 3 there. So if a number divides 2010, then that base b representation is going to end in the digit 3 because it'll have a remainder of 3, except for some special circumstances that we'll talk about. But the way that we'll figure this out is basically by finding all of the numbers that divide 2010. So the way to do this is finding the prime factorization of 2010, which is 2 times 3 times 5 times 67. Therefore, the number of divisors of 2010 is going to be 2 to the 4th, which is 16. However, there are not 16 positive integers b such that this is true. And the reason being there is because of all these numbers. So we're thinking, we're looking at like, 2, 3, 5, 67, and then getting into like 2 times 3 is also a divisor, 2 times 5, etc. There are 2 to the 4th of these. It's not 16 because the base 1, basically the base 1, 2, and 3 representation of 2013 won't include the digit 3. Like the digit 3 is not in these base representations. So we can exclude these 3 from that 16. So actually, the number of base b representations that exist, all these others will work, are going to be 16 minus 3, which is 13. So the answer is choice C.